Hello students, welcome to my channel Study with Alakesh. As of now, we have discussed the basic definition of force and its different types. So today we are going to study about the stress. Alright, if we see the basic definition of stress, then it is restoring force. Stress is basically restoring force per unit area. In order to understand what is restoring force, let's take an example of this body. Here, this is a which is cross-sectional area. Basically, if you are considering like this, the 3D aspect, then this is the area. Are you getting my point? This is the area, and the load which is represented by P, it is acting normally in this surface, on this surface. Okay? Now, so this is the load that basically we are applying. So this is called applied load or applied force. Okay, so basically in strength of material, the force is normally called as load. Alright, so this is the applied load which is applied externally. So, and if we see the diagram of the load, then it is tensile in nature. Okay, it is tensile in nature. That is, it is going away. Okay, it is going away from the surface. Okay, so its intention is to elongate the body. Okay, here main come to over here length to the body side. So it is a tensile load that is acting on this surface with cross sectional area A, and it is acting normally because the angle is means the 90 degree. But if you take this surface, then since we are applying one force on the surface, so according to the Newton's third law, a similar equal and opposite force will be get developed in the other side of this surface. So basically, if we are drawing the surface like this, so if we are applying a load P, then automatically due to the applied load, a same amount of load, that is P, will be developed on the other side. Okay, equal and opposite, that is the Newton's third law. Okay, so if we are considering, so this load is called as restoring force. What does it mean by restoring? That means this force will try to deform this surface in this direction, right? So intensity of this force will be getting back the surface on its normal stable position. Are you getting my point? And same thing will happen here also. Now, if we remember another term called pressure, okay, it is what? It is nothing but applied force per unit area. Okay, applied force per unit area. Now, if we compare these two terms, the main difference is here we are using the restoring force, here we are using the applied force. Are you getting my point? Here we are using the applied force, and here we are using the restoring force. Otherwise, if you find out the SI unit, it will be what? It will be the Newton per meter square, and here also the SI unit will be Newton per meter square. So dimensionally both are equal. Are you getting my point? But but the main difference is the pressure is developed because pressure is then exerted by the applied force, and stress is developed because of the restoring force. Are you getting my point? So if I have to say in a body pressure is always applied, pressure is always exerted, pressure is always from the outer, and because of that pressure the body develops stress inside the body. Dimensionally both are same, the Newton per meter square, and in pressure we call this term as Pascal. Okay, we call this term as Pascal. So therefore we use the same thing here also, we call it as Pascal. So 1 Pascal equals to 1 Newton per meter square. Are you getting my point? So this is stress. Stress is nothing but it is, and don't use applied force per unit area because this is pressure. Are you getting my point? Main concept is stress is restoring force per unit area. Dimensionally both are equal. Okay, dimensionally both are equal. And what will be the dimension? If we have to follow the units, the Newton per meter square. So what is the dimension of force? It is mLT minus 2. And what is meter square for? It is L to the power 2. Okay, then so what will be the answer? It is m L minus 1 T minus 2. Are you getting my point? So the dimension of stress and pressure is same. It is m L minus 1 T minus 2. So you have understood the basic idea of what is the stress, what is the difference between stress and pressure. So dimensionally they are not different, then both the dimension is same, but main difference is stress is related to the restoring force and pressure is related to the applied force. Although both are numerically equal, but conceptually these two are this is the main difference between stress and pressure. Now the different types of stress, here we are discussing tensile stress, compressive stress and shear stress. These are all depending on the nature of forces that is applied. Suppose if you see in case of tensile stress, the force is tensile in nature. Okay, so what is stress? P tensile, that is tensile force by area. If you see in compressive stress, the force is compressive in nature. So what is sigma c? It is PC by area. Now in case of shear stress, what is the shear stress? It is nothing but PS, that is means shear force by the area. Sign convention basically we normally take tensile force is positive and compressive force is as negative. Are you getting my point? Tensile force as positive and compressive force as negative. It is not necessary that tensile force has to be positive, compressive force has to be negative. That is why it is convention. That means we are considering it as a positive and it as a negative. You can also consider it as negative and it as positive. So according to that, tensile stress is positive and then the compressive stress will be negative, because since area is always positive. Alright, so in brief, if we have to say, tensile stress is related to the tensile force, compressive stress is related to the compressive force, and shear stress is related to shear force. Okay, and the SI unit will be Newton per meter square, all right, or Pascal, all right. And the sign convention is always be like this, okay. Or if only one force is applicable, then no need to consider this sign convention. By default you can go with positive only. So we'll see those questions, then this kind of things will get cleared out, okay. And if you like this video, then share it, subscribe the channel. Thank you, take care, goodbye.